Okay, Assalamualaikum warahmatullahi wabarakatuh. Welcome to the course Soil Erosion and Conservation. You are with me, Nurul Huda Muhammad Ramli. So the topic of today's lecture is types of erosion. So our learning objective is that students will be able to evaluate causes of erosion and methods to control the erosion. So there are many types of erosion. We have raindrop erosion, street erosion, gully erosion, streambank erosion, river erosion, glacial erosion, snow erosion, organic erosion, anthropogenic erosion, scale of erosion, underground erosion, and tunnel erosion. So you must be wondering how this erosion looks like and how they happen and how can we control them. So we will try to answer this question in this course. So first we go to raindrop erosion. So in the first part we will learn about the process of raindrop erosion and to calculate kinetic energy of rainfall. And also we will learn on how to calculate the amount of soil eroded by raindrops. And finally there will be an exercise that you have to submit via Putra Blast. So in the second part of this lecture, we will learn on how the transportation distance of soil particles in splash erosion, raindrop size, and we will learn how to calculate terminal velocity of raindrops. And finally, we will have to do some exercises. So in this topic, kinetic energy and terminal velocity will be our focus. So first, we look at process of raindrop erosion. So raindrop strikes open moist surface. So when this happens, it forms a crater. And from the impact, a blast which bounces the soil and water up will happen. Okay, the blast return back around the crater and the soil may splash into the air up to a height of 50 to 75 centimeter depending on size of raindrop. At the same time, the soil moves horizontally as much as 1.5 meter on level land surface. On sloping land, more than half of soil move with runoff. So you can easily imagine how these things can happen because we have a lot of rainfall here in Malaysia. But imagine if this process happen again and again, what will happen? Of course, erosion will happen because of raindrop. Okay, so this is raindrop impact on a sandy surface. This video was made by a group of researchers from the University of Minnesota. So let's see the video together. So in this test, a 3 millimeter water drop impacting a granular bed with impact velocity of 1 meter per second. You see the water drops on the granular bed and it forms a granule which bounce back on the surface and up and settle. So now we have higher impact velocity, 3.3 meter per second, with the same diameter of water drops. So the impact now is higher. It bounces up and down again. And it forms a granule. And this is the imprints from the impact. So now we have a higher impact velocity, 5.4 meter per second. So you see, we have a higher impact and it creates a splash. So it's different from what you've seen before. So this is the result from different impact velocity. So as you see, this is when the impact velocity is small and it leaves an imprint something like this. So as the impact velocity goes higher, at this 2.1 meter per second, it forms a granule, and this is also a granule, small granule of course. And as the impact velocity goes higher, it forms a splash, and this splash will cause soil erosion. Okay. Okay, the repetitive process by raindrops will cause soil erosion. Is it because of the momentum or kinetic energy of the raindrop? So majority scientists reported that it is due to kinetic energy of the raindrop. Kinetic energy, which can be calculated using this formula, causing detachment of soil particles from land surface. Yeah, so the kinetic energy causing detachment. Kinetic energy is related to raindrop size and distribution. And it also can be calculated as this formula. Okay, you have used this formula before to calculate erosivity. I hope you still remember. So from this equation, the kinetic energy, the unit is metric tons per hectare per centimeter of rain, and the unit of rainfall intensity is in centimeter per hour. Okay, so now we will learn how to calculate kinetic energy of rainfall. So one of the method is by using terminal velocity and rainfall intensity. Okay, kinetic energy is related to the terminal velocity of rainfall given as this formula. So kinetic energy is in watts per square meter is equals to rainfall intensity in millimeter per second times by impact velocity of raindrop before impact is V. The unit is meter per second. So another way to calculate kinetic energy of rainfall is by using terminal velocity and mass of raindrops. So in the previous formula, here you use rainfall intensity, but now you are using mass of raindrops here. So if you are using this formula, the unit of kinetic energy will be in kilogram per square meter per square second. So M will be mass of raindrops. The unit is in kilogram. So you also have to use terminal velocity. Yes, and now we look at the formula for calculating the amount of soil eroded by raindrops falling vertically. So this is the formula for calculating quantity of soil eroded by splashing. So there are many parameters involved, as you can see here. So gamma is density of soil saturated with water. I is rainfall intensity. Vc is terminal velocity of raindrops. And G is gravity acceleration. dk is mean diameter of raindrops. And ddk is diameter of raindrops of the critical size below which splash erosion does not occur. And all this part of this equation is multiplied by 4 sine alpha. So alpha is angle made between the line of vertical fall of the raindrop and the ground surface. So you have another one parameter here, VCD. This is critical velocity of falling raindrops below which there is no appreciable soil damage. So this is the formula to calculate it. So M is coefficient of friction, C is cohesion of soil when saturated with water, and this is density of water. So normally these values can be used in calculation. This is approximation values. So you will have a chance to use the previous to use this equation, this formula in the exercise. So this is the exercise that you must submit before 17 March 5 p.m. Okay, so let's read the question. Calculate the amount of soil eroded by splashing from a plot of 1.5 times 1.8 square meter size. The other details are as follows. So you have all these parameters. Just plug in these parameters into the formula I showed you just now, and you should get the answer around this value. So that's the end of the first part of soil erosion. I'll see you in the second part of soil erosion in the next video.